Hi, in today's video I'm going to be talking about how to edit videos with Ffmpeg, MPV and emacs. Now in a previous video I showed you the MPV-EL package for emacs that allows you to control MPV. And I've been doing a lot of work on this and writing some scripts that will allow you to easily capture timestamps from MPV and use those timestamps to create clips from the video. So what I'm going to do is run meta-x MPV play. I'm going to open this video, which is Elephant's Dream, which is a video by Blender. It's an open source video, and I've got emacs MPV selected here. I'm going to press capital O on the keyboard, which is going to show the on-screen display and show the timestamps. And in the previous video, I showed you how to enable fractions in MPV's output by editing the config file and adding osd-fractions, your mpv.config file. And this is going to come in handy because we're going to be trimming stuff to the millisecond. So I've got emacs open here, and what I'm going to do is press F2 on the keyboard and then space, which is going to pause the video. And what you'll see is we have this interface come up down here, and this is a hydra. Basically what's happening here is we've now entered a mode where we can control MPV, and our keyboard input is going to be sent over the JSON interface to MPV and allow us to control it. And these are the keyboard shortcuts that we've got that allow us to seek into the video and perform some functions. So what we've got down here is HJKNL to seek backwards and forwards. We've got comma and period to go forward and backwards a frame. We've got space to pause, Q to quit, and we've got these three options here: insert playback position, insert new line, and take a screenshot. So what I'm going to do is come through and actually grab some time codes and then take those time codes and use them with Ffmpeg to cut the video up into clips to the millisecond. So now that I'm in this MPV mode, I can advance through the video like this, and you can see the time code. So what I'm going to do is come across and just find some clips. So what I'm doing here is pressing period on the keyboard, and you can see we're moving forward. So I want the first clip to be the first frame here. So what I'm going to do is press I on the keyboard, and you can see that inserts the current time code into the org file that I've got here. Now what I've got down here as well is this option called N, insert a new line. And this is needed because when you insert a timestamp, it does it where the cursor's position is. So if I press N on the keyboard, what you'll see is that we create a new line, the cursor moves down, but it doesn't go into insert mode. And so I'm still in this emacs mode here. I'm in this MPV mode where I can control the video. So let's come through and just move forward a bit and just take this as the second clip. So if I press I again, you'll see that it's now inserted another timestamp. So what I can do is keep doing this to generate start points and endpoints for the clips I want to create. So I'm going to press N. As you can see, I'm not actually in emacs. I'm not in the emacs buffer. I can't move up and down. I'm still in this MPV mode. So I can come through here and let's just randomly create some clips. So insert another timestamp, press N. Okay, we'll stop it there. Advance it a bit and press I again, and I'll go through and create another one. And do I again. So that's all the timestamps inserted. So what I'm going to do now is press Q on the keyboard, and that's going to quit MPV. If I now press any key on the keyboard that is not listed here, it's going to exit the hydra mode. So I'm going to press W, and that's going to return me to emacs. So now what we've got here is a series of timestamps that are basically the start and the end point of these 3 clips that we want to create. So what we're going to do is 2 things. I'm going to show you how to do this on the command line with some scripts that I've written, and also entirely within Emacs, so that you can capture the time codes, convert them into a format that Ffmpeg uses, then run Ffmpeg from within Emacs and create all the clips. So the first thing that we want to do is we want to export this block of code to a text file so that we can use it on the command line. Now this block of code is an example block of code. It's not an actual source code block. If you have a source code block like a block of code for Shell or Python or something like that, what you can do is actually export the code and the results. But because this is a example block of code, we can't run Control-C, Control-C to actually export this. So what I'm going to do is show you a really nifty feature of org mode you might not be aware of, and that is taking something as standard in. So what we've got here is this block of code called timestamps, and what we have down here is another block of code, and this is a shell script block of code. So we've got the name, we've got the header, and you can see the header says results file timestamp.txt. And what you'll see down here is begin source sh and then sd in timestamps. And that's basically taking this block of code timestamps here as standard in. So just imagine we've got this timestamps block of code. So imagine timestamps, cat timestamps. What we're essentially doing is piping it into this next block. So what we're basically doing is running a command like this. What we're doing is we're taking the timestamps block here, we're catting it into org and printing out the file, and then redirecting that file into a text file. So what you can see here, we've got the standard in, the output timestamps, and we're printing the actual contents of the file. So when I run this, Control-C, Control-C, what you'll see is it's created this timestamps file here. So you can see that's the block of code has been exported into a timestamps file. Okay. So now we've got this file here, these bits of time codes in a file on the desktop. So I'm going to switch across to the terminal here, and what you'll see is we've got this timestamps file here. Now, if I open this, the problem with this is Ffmpeg takes a start point and a duration to create a clip. What we've got here is the start and the end time. So if you start use Ffmpeg to record a clip starting at 10 minutes, and you give it the next option where you've paused, taken the timestamp at 15 minutes, what it's going to do is it's going to create a 15-minute clip. It's not going to create a 5-minute clip. So to create a 5-minute clip, you have to have a start point of 10 minutes and a duration of 5 seconds. So what we need to do now is actually convert all these timestamps. What we've got to do is convert this hours, minutes, seconds, milliseconds into seconds. Then what we have to do is we have to subtract the start point from the duration, from the end point, to give us the duration. So what I've done is actually come up with some org code that does this. So I'm going to run the script clip time, give it the -h option. Basically all you do is give it input and output. So clip time, input is the timestamps. I'm going to give it an out file called cut list. I'll show you the difference. So cut list. And what you see now is we've got this new format where we've got the start time, comma, and then the actual duration. So these are all the start times of the clips, and these are all the durations. So let me just go back to this one here. So you can see we've got 6 entries here. So that's the start, that's the end, start, end, start, end. So what this has done is it's taken the start point here, and it's basically subtracting the start point from the end point to give us the duration. So 9.75 to 25.292 is going to be a duration of 15.542 seconds. So this automatically does the calculations, and it puts it in this format here, which is basically like a CSV format. The reason why I do it like this is so that it's obvious how they're related. So you can see these are sort of one thing, a start time and a duration. So what I'm going to do now is run the next script called scene cut -h. You can see that just takes an input and a cut file. So the input is the video file, and the cut file is the thing we just created. And what it's going to do is going to go through input, cut file, and it's going to go through, seek to those positions in the video and cut it up into clips. So you can see here, going through and creating the clips. So now what I'll do is I'll just switch back to Emacs, and what you'll see is we've got these 3 clips here that I can now open. That's clip 1. Second one. And third one. So that's how we take the time code that we inserted with MPV and exported them, ran 2 scripts and chopped the video up in a couple of minutes. So what I'm going to do is actually go through and show you how you can do the same thing within Emacs. So what I'm going to do now is show you how we can run the same script. So this big chunk of code here is a load of org code, and what this does is it takes the hours, minutes, seconds, milliseconds, and converts it into seconds, subtracts the start time from the end time to give us the duration, and then it converts it back into hours, minutes, seconds, and then formats it into that sort of CSV type sort of layout. So what we've got here is we've got a block called minutes, we've got header, results, raw, draw, and again what we've got this section here, SDN timestamp. So that's going to take this code here, the standard in, and pipe it into org, and then what it's going to do is it's going to display the results in a drawer. So if I now have my cursor positioned inside the source code block and run Control-C, Control-C, what you'll see is it spits out the results the same way that I did with the clip time script on the command line. So what you can see here is we've got the start time, duration, the start time, the duration, and the start time and the duration for the 3 clips. So that's that. And what I'm just going to do actually is delete those clips there, because I'm just going to recreate them. So now what we've got is we've got this block here called minutes that has got the timestamps in the correct format for Ffmpeg. So now what I'm going to do is show you the Ffmpeg code, and I think you need to change this to input mkv. So what we've got down here is another block of code. This one's called Ffmpeg, and you can see here what we've got is 2 header variables. Now these are like basically creating a variable inside a shell script. So same way you might create a variable called input, which was equal to the name of a video, we can do the same thing with org source code blocks and actually pass that into the code. So again, what you can see here is we've got the, make sure that I want the minutes here, so this should be, I need to change the standard into minutes. So what we've got here is the standard in minutes. So we're taking this block of code here and we're going to pass it in to this. Let me just hide these. So now what we've got is this block of code. So there's a couple of bits to it. Let me just come through. We've got the input up here. And you can see this input is being used by these two bits here. And what this does is it gets the file name without the extension. So the file name will just be input. And that's going to be used in this block here, this input name count, which I'll get to. So the first thing that we've got down here is this count while ifs equals comma read r start duration do trim video count done. So what's all this about? So as I showed you the format, let me just come back to the actual format. So you can see the format we're dealing with here is we've got two time codes separated by a comma. We've got the start and then the duration. So what this does, we're piping that block of code into this, and what it's doing is it's going to read it line by line, and the field separator that it's using is the comma. And what it's going to do is anything before the comma it's going to set to the variable read, and anything after the comma is going to be set to the variable duration. So I'm going to go through each line, look at them separated by the comma, set first bit to read and the second bit to duration, and then what it's going to do is it's going to run this trim video function, which is this bit up here. And what you're going to see is we're basically passing in this start and this duration. That comes from this block down here. So every time it reads a line, it passes in read and duration into this function here and here, and that's basically how we tell ffmpeg to seek to a certain point and then create a clip. Now what we've got up here is this output equals input name dash count.mp4, and this input name is the input name from here, which is the input from the variable set up there without the extension, and the dash count is taken from down here. So every time that this loops through, goes through a line, what it's going to do is it's going to increment the count. And what we're basically doing is creating a file name called output, which is going to be equal to input dash count.mp4. So it's going to be input dash 1, input dash 2 for each line, and so on. We have to set that up here. Now this no SDN, this is vital. This is what actually makes this whole thing work with the read command down here. If you don't have this no SDN, this technique won't work. So by having this bit of code no SDN, it's going to allow us to use read to read the file line at a line, set the variables read and start, and then pass those to the function trim video, pass those variables into the function, and going to keep doing that for line by line. So it's going to go for the first line, go to the start, set the duration, create the clip, go to the next line, create the next clip. So that's basically how it works, and why having the timestamp separated by a comma is actually useful, because one, it shows us that they're connected, that's a single clip, and secondly, we can then use the comma as a delimiter and actually set these variables and pass them into the function. So what I'm going to do now is actually run this function. So there's another issue that I want to cover, is that when you run a source code block in Emacs, what happens is while it's running, you can't interact with Emacs. You've got to wait for the code block to finish executing. Now there is a package called ob-async, and you can add a option. You can add that option down here that's sort of like :async, and what that does is it executes the command in the background. But what I found is sometimes it works, sometimes it doesn't, and it can be a bit sort of finicky. So what I'm just going to do here is run Control-C, Control-C, and what you see is, you can see we've got this little timer. Can you see the little timer? My cursor's turned into a timer and it's not allowing me to do anything. You can now see code block evaluation complete, and what it's done is actually put the standard out here. You can see these are the this is the output you'd normally see in the terminal. So if I now switch back to the desktop, what you'll see is we've got those three clips recreated, and I can just open them up again. So what we've done is the whole workflow inside Emacs. We've captured the timestamps using MPV, inserted them into the document, and then we ran this next block of code, this org block down here. Then put these timestamps here. So we've got the timestamps there. We ran the org block and it gave us the results like that. Then we had ffmpeg take that input in, use read to loop through that input line by line, set the variables, and pass it into the function that basically chops the video up. So two ways of doing it. You can either do it on the command line, or you can do the whole thing through Emacs. And I said the only thing about doing it from within Emacs is that while the source code block is running, you can't do anything with Emacs. You've got to wait for it to finish. I said there is this async package that allows you to run stuff in the background, but sometimes you get this error in process sentinel, and it's a bit annoying. You've got to sort of quit Emacs and restart it and stuff. So that's what I've been working on, how you can easily capture the timestamps from a video. So close these. So of course you could open MPV and, you know, have a text document open and, you know, advance to the frame in MPV and write it down like that for each one, but it's much quicker just doing it using the MPV package. So again, on MPV play, I open the video. Let me just check this. That's the wrong video. That's one of the clips. So capital O on the keyboard shows the time codes. And I've got Emacs focused here, and I just press F2 and then space, and it's going to start playing. Press space to pause it. Press N for a new line, I to insert the timestamp, new line. And again, I'm not going into insert mode in Emacs, so I'm not like shifting between Emacs and MPV. It's all this MPV mode, and I can add the time codes in this mode and still carry on seeking through the video. So I can come through, seek through the video, add another time code, new line. And and then basically exit. So if I press F2 space, I can press Q to quit. See, these are all the keyboard shortcuts we've got. The other one I should actually show you is the take a screenshot. So again, we've got the seek commands, H, J, K, and L, seek backwards and forwards. We've got period and comma to go, period goes forward, comma goes backwards. We've got space to pause, Q to quit. As I showed you, we've got the insert playback position and insert a new line. And also we have take a screenshot. So if I press S on the keyboard, you see you don't get any output, nothing shows up. Normally if you're in MPV and you press S on the keyboard, what you'll see here is it says screenshot saved, MPV, you know, -- 2 or whatever. So I'm going to quit MPV by pressing Q and exit the mode by pressing W. And if I just switch back to the desktop, what you see is got these two charts. You can see me opening it with SKIV. So those were the screenshots taken with MPV using Emacs and also directly using MPV. And the way that it works is when you're using Emacs and you've got the video open and you run the screenshot command, it's going to take the screenshot and save it to the directory where Emacs was opened. So you open Emacs on the desktop and you open the video, you know, from the desktop or whatever, it's the actual buffer location. So this, I was inserting everything into this org file here, and so that's where it's basically saved stuff to the same directory. So if you're sort of searching for where this actually gets saved, that's where it gets saved. So what I'm going to do now is actually go through the code and the script. So first of all, what I'm going to do is actually go through my Emacs file and the actual code here. Okay, let me come up here and put one down. So this first bit of code is the normal bit of code that's on the MPV EL wiki. Now what I've done is given all the functions that I've written custom namespaces, and I'm loading them after the MPV package is loaded, so that way it doesn't sort of interfere with anything else, because I found if I didn't give them custom namespaces, it broke things like the org timer. So first of all, what we've got here is we've got the insert playback position, and this is how you insert the actual playback position using meta return. So you can actually press meta return in an org timer list, and it will sort of put in the time code in an org timer format. And what this bit here is this is the insert playback position. So what you can see here is with eval after load MPV. So that's basically saying after the MPV package has loaded, evaluate this code. And what you can see here, we're defining this function and giving it a custom name prefix of my, so like my MPV insert playback position, so that it overrides the code and sort of sets our own custom namespace so it doesn't sort of mess with anything else. And what we've got next down here is seek to position at point. So again, custom namespace here. And what we've got here is the regular expression that I had to modify. So this is the extra code that I've added for the regular expression so that it matches hours, minutes, seconds, and milliseconds. So dot 0 to 9, and you can see here we've got this question mark. So you can either match something without milliseconds or with milliseconds, and that's the sort of bit of code down there. This is the one of the keyboard shortcuts. So when your cursor is over a time code, you can press Control X comma, and the video will jump to that point in MPV. So you can basically have all the timestamps of stuff that you've captured or you want to seek to, and you can just put your cursor over the position, go Control X comma, and once you've got MPV opened with MPV play, it's just going to jump to that location. The next bit, what we've got down here, is the org timers convert seconds and milliseconds to hours, minutes and seconds. So what I'm doing here is, let me see if so this is another bit down here that I forgot to mention. Insert playback position. By default in the mpv.el package, this is set to round time. And what that does is that rounds up the time to the nearest second. So if you were at 9.5 seconds or 9.6 seconds, say, what it would do by default is it would round it up to 10 seconds, so that if you had your playhead at 9.6 seconds and you, using the default package, you inserted the timestamp, it would insert the timestamp as 10 seconds. Okay, it's no good. So that's why we have to change the round time to float time, so that we get the precision, get the precision to milliseconds. So again, that was the float, that was the regular expression, and this is where the float string goes into this my org timer sets to hours, minutes, seconds. And basically what we do here is the format is going to be 00:00:00.000. So what we want to do is actually split the string at the dot, and anything before the dot is going to be the seconds, and anything after the dot is going to be the milliseconds. So what we do here is we set x to be equal to s, which is the float that's coming in, but we have to change the float from a number to a string. So what we do is we set x equals number to string s, so that converts the float s into a string. Once we've done that, we can manipulate it. We can say seconds car, and what car is, you have car and cadre, I think it is, and that's like the head and the tail. So before we got the seconds, car is before the period, and cadre is after the period, so that's going to be the millisecond. So once we've done that, what we then do is we then convert those back into from strings back into numbers. And what that allows us to do is move on to this next block of code, where it basically does the sort of conversion of hours, conversion of seconds into hours, minutes, and seconds. And what we basically do is we just end the milliseconds after the calculations. So by splitting the seconds and the milliseconds, we can get it to calculate all the seconds and just append the milliseconds to it. And what we've got down here is the opposite, where we're converting from hours, minutes, and seconds to seconds. And again, what we've got here is this regular expression that matches dot and the milliseconds basically after the period. And what we do down here is, these are regular expression groups. So if you have a look here, you see got group 1. So that's the first group. That's the second group. And this is the third group. And finally, what we have here is the fourth group. And the reason this is important is because what you can see down here is these things here. What this is doing is it's setting these variables like h, m, s, ms to be equal to a string match. And you can see what we've got here is match string 1 HMS, and HMS is the input. So what this is doing is say match the first regular expression group, and that's the first. That's going to be the hours. The second one is going to be the minutes. The third one is going to be the seconds. And the fourth one, which is down here, is going to be the milliseconds. Then after that, what we do is we do the maths, and basically what I'm doing is I'm just appending the milliseconds after it's done the calculations. That's why we need to split stuff up, so we can do the calculations and get it to all work. And then what we've got down here is the actual MPV command. So we've got frame forward, and what this does is this runs this mpv-enqueue function that is in the mpv.el emacs package. And what we're doing is we're sending this frame step command, and that's an mpv command to step the video forward one frame. And then we've got the verse here, we've got frame back step. So that's so we can create keyboard shortcuts to go forward and backwards with period and comma. Then what we have down here is MPV take a screenshot, and again that's using the MPV-enqueue command or function, and we're sending this screenshot command, which is an MPV command to take a screenshot. And then finally what we've got down here is add a new line in the current document, which I found on Stack Overflow. And basically this is what inserts the new line and moves the cursor down. And then finally what we've got down here is the actual hydra, and this is the interface that comes up when we press F2 on the keyboard. And what you'll see here is we've got seek, actions, general. And we've got two sections. We've got this section in the double quotes, and then we've got the commands listed down here. So you can see H corresponds to H, J to J, K to K, L to L, and so on. So that's how you actually create this little pop-up, basically. And what we've got here is when you press these keys, it's going to execute these functions: MPV seek backwards, forwards, by 5 seconds, 60 seconds, MPV frame back, frame forwards, pause, kill, take screenshot, insert, playback position. So those are the hydras to actually generate the interface. So let me just switch back to here and show you the interface again. So when I press meta x MPV play, and now I'm back in, let me just move that by the side. Now I've got Emacs focused, and if I press F2 and then space, it starts playing, and we've got this window come up, and that's what the hydra is. That's how we create that layout with all the keyboard shortcuts. So again, I can press Q to quit that and W to exit. So that's the code for Emacs. So what I'm going to do now is come through and show you the time clip script. And this is basically the same code that we're running inside Emacs, but this is just doing it on the command line. So what we've got up first of all here, we've got the shebang. This is a shell script, not a bash script. So the reason for that is because it makes it more portable. What we've got here is this usage function, so that if you run the script without any arguments, it will display the usage, or if you run the script with -H, it's going to display the usage. We've got some error messages. We check if the script is run without any arguments, and if it is, we run the usage function. Then what we've got here is get ops, and this is how we create the -I and -O options in the script, so that you can run -I, give it an in file, -O, and then give it an out file. And so basically what this does is anything after -I is going to be set to equal input, and output is going to be the output name. And we've got other stuff like here, h is equal to the usage. We have these two other things here that basically, if you provide an incorrect argument to something, if you don't give it an argument, if you run -i and don't give it a file name, it's going to throw an error. So you can see these sections up here, :IOH, correspond to the same things in the case statement. And then what we've got is this section here, the variables. This is basically how you can get the input file name without the path and the extension. So if we give it a video on the desktop called input.mkv, it's going to chop off the full path and then chop off the extension to just give us the file name. And we use that in the script so that we can give stuff an automatic file name if we need to. And what we've also got here is the output default. So if you don't give the you can basically set an output default if you don't give an out file. So it will take the input file name, dash cut list, and the date and the time. What we've got here is these two blocks of code that convert either seconds or hours, minutes, and seconds, and take the start point, subtract it from the end point to give you the duration, and it will then sort of save it in a text file. So basically, we give it the list of timestamps. It goes through it. It converts everything. If you give it in seconds, it'll convert it. It will do the subtraction and print it back in seconds. If it's in hours, minutes, and seconds, it will convert it into seconds, track the start from the end point, give it the duration, and convert it back into hours, minutes, and seconds, and then rearrange it in that CSV type output. And what we've got down here is some code that will check whether the format that you've given the script is in seconds or hours, minutes, and seconds, and then run the correct function. So we basically check what format it is, if it's in seconds or hours, minutes, and seconds, and then run these awk functions here. And you can see this awk function is the one that I was showing you in the emacs config file. So that's the clip time script, and I'll just go through and show you the scene cut script. Cut. So same sort of setup here: usage, error messages, get ops, variables. And what we've got down here is the same bit of code that we're actually using in Emacs. We get the file name without the path. And what we've got down here is we've got the count and the while read loop. So it'll basically go through each line and separate stuff by the comma and set the first bit to read, the second bit to duration, and then pass it into the ffmpeg function script here, block of code rather. It'll pass in the start and the duration and then create the clip. So it will basically go through each line, seek that point in the video in ffmpeg, and create a clip for the duration. So exactly the same bit of code as we had in Emacs, but we're just doing it in a on the command line instead of Emacs. The only difference here is we're actually redirecting the cut file in from a file, whereas in Emacs we were taking it in from standard in. So those are the scripts, and that's how easy it is just to take timestamps really quickly. So again, do it once more. Let's just so I'll just go through the whole thing again quickly. So MPV, open the video. We've got the video open, press capital O in MPV to show the timestamp. So now we've got Emacs focused here, and what we're going to do is press F2 on the keyboard, press space, you can see pause. So I insert the timestamp, N move to the next line. Again, we're still got MPV focused, which is a nice thing. See here, now timestamp, new line, move it forward a bit. We'll just do some random bits. Next line, nice shot. So it's really quick just to come through the video. Okay, that will do. Now I can press Q on the keyboard to quit MPV there. I'll press W to exit out of the hydra. Now we've got the timestamps here. We want to export them. So we have this block of code here. Again, we're exporting the results to this file timestamps, and we're taking the standard in from timestamps. So Control C, Control C. You can see now we have the timestamps file here. Let me just remove files. Put the timestamps. Let me just remove the JPEGs as well. Okay, so we've got the timestamp at timestamps. So we need to convert this. So clip time in timestamps out cut list .txt done. That cut list. You see we've got the cut list now. We'll run scene cut then -h. Just give it the input file, which is the video and the cut list. Scene cut in input C cut list. That's going to cut up the video. And the last clip was a bit longer. And you can see input 1, 2, 3.
Email this way.
Yeah, it was 20 seconds. Clip starting here.
You're not paying. Email, look, I mean.
Final clip.
And you want?
So now let's do the same thing all from within Emacs. So we're going to remove the cut list, remove the cut list, timestamps, and remove those files we just created. Okay. Right, so we've already got the timestamps. So the next step is to come here. Let me just delete this. We just run Control C on this block. It's going to give us the timestamps there. Come across to Ffmpeg and Control C, Control C. You can see the little cursor turned into a little watch. So while that's there, you can't do anything with Emacs. Now it's finished. Clip 1. Clip 2. And clip 3.
And you want?
So there we go, trimming stuff to the millisecond with MPV, Ffmpeg and Emacs. And again, you could sit there and just open MPV and manually type out these time codes, but it's so much more convenient using Emacs to capture the time codes in a block. And again, once we've done that, got the time codes, you can export the block to a text file, switch to the terminal, just run clip time, convert that, then run scene cut, and it's going to cut it all up. Or if you want to be hardcore, you can just do it all in emacs. You can have it, you can take those, you can convert the seconds into this CSV type format. Once you got that, just come across to ffmpeg, run the source code block again, and it's going to take the standard in from here. And again, what it's going to do is it's going to go through it line by line with read, passing the variables to this function here, which again, the no stdin vital, and then we have the functions that get passed in, the start, and you can see the input, this input here, that's coming from up here. So it's just like having input in a written in a shell script. And we've got the output name, which includes the count, and the input name, which is the input without the extension. And it's just going to go through, seek to that point in the video, and create the clips. So really nice, easy workflow that you can either do everything inside Emacs, or you can just use Emacs to capture the timestamps and export them, and then run the scripts on the command line. And it's just going to go through and seek to the point in the video. And again, I open MPV here, MPV play, MPV. We just move this back across, and let me just start this. Oh. Need to put the time code here and switch back. And what I'm going to do is I'm going to exit the hydra here. And now I've got my cursor. I'm in Emacs here. What I can do is I can press Control X, comma, and the video is going to jump to the timestamp under the cursor. So you can see here, and you can see the time code here corresponds exactly to what's here. So it means that you can actually just go through and view all your points. So obviously, you're creating clips, you're going to be taking 2 points, the start time and the end time. Yeah. So that's the start and that's the end, so on. So once you've done that and you've sort of exported them, and you'll end up with the format like this, because as I said, ffmpeg requires a start time and a duration, which is why we have to do the maths and tract the start from the end point to give us the duration. And then we also have to make sure that we've got the start point, then the comma, and then the result of the calculation here. And also, don't be tempted if you're using this script to put in headers like start and duration. Don't do that, because then it will break the script. So don't do that. Just leave it in that format. But I just felt that format makes sense, because you can see each of these is one thing, the start and the duration. And again, it turns out it's a perfect format to actually use with this while read loop. So again, we set the separated to be the comma, what's before is read, and what's after. So we've got start and then duration here. So that would be that start, and then after the comma is duration. And then we pass those in to this function here, start and duration, and that's what does the business. So interesting things you can do with org mode. Again, you can't export a example code block here, and you can't use another source code block. You couldn't set this to be a shell code block because it would give you errors. We have to use an example code block here, give it a name, and what that allows us to do is take that as standard in to this other source code block here. Just runs awk, and again it's like catting timestamps, typing it into awk, and then redirecting it into timestamps.txt file. That's basically what this is doing. So that's how you could take the timestamps with Emacs and MPV, and let me just quit that, and then export them into a text file, and then run the clip time script on the command line and the scene cut script. But if you just want to do it in Emacs, you can. We just create this other block here, give it the results draw. Again, we take the start and the STN from timestamps, and it creates this draw here. You can see the advantage of the draw. You can toggle it open and close. That's why we put it in a draw. Makes it nice and clean. And also, talking about that, you'll see this option up here, startup hide blocks. And what that does is, when you open the org document, it collapses the source code blocks by default, so that it makes it easier to go through. So that's the results there. And as you can see here, the Ffmpeg block, we've got a variable. We can use the header block to set a variable. Input equals input.mkv, or whatever your input file is. We take the standard in, and we just pipe it into this, and it's going to go through and basically chop everything up. And so there is a thing called the OB async. We can add this async parameter to these options, and it will run it in the background, but it's just flaky. Sometimes it works, sometimes it doesn't. Sometimes it gives you this error in process sentinel, so it's a bit annoying. So that's the only issue about running it through everything through Ffmpeg. If you've got a lot of stuff, doing a lot of clips, obviously it's going to take a while to complete, and you can't return to Emacs till it's done. So you may want to actually do the last step on the command line, but you can do it in Emacs. As I showed you, you can do, you've got a bit of flexibility on how you use this. You can either do it all through Emacs, or you can do some of it on Emacs and some of it on the command line. But it's just much more convenient way to be able to actually capture clips quickly. So it's just really easy to go through. And the other advantage of this is that you can, you can come back in here and actually run the keyboard shortcut to jump to these points in the video. So you see you've actually got everything right, but it just makes it really easy to capture all the timestamps, much easier than having the video player open and writing these all down by hand. And of course, the problem is, as I said, can't just give Ffmpeg these timestamps. Yeah, can't. If I was to give Ffmpeg this, it would say start at 1:14, and we give it 1:35. What it's going to do is it should create a 19-second clip. If you give it 1:35, it's going to create a 1:35 clip. So that's why you have to actually do the maths and subtract the start time from the end time to get the duration, and then have the start time and the duration. And that's what this code does down here. You can see this converts it, does all conversion from hours, minutes, seconds to seconds. The next line, it does the subtracting the start from the end to give you the duration. And then the next bit of code is it's converting it back from seconds to hours, minutes, seconds. And finally, this final block of code to this ORS equals end to all this stuff. what that does is that gives it the CVS type format, so that we get this output with the start and duration that will work with ffmpeg. So I'll put links to all this under the video, and it's really easy to use. You can just capture timestamps quickly. You know, you've got convert the code, give it to the scene cut clips, cut script, and it's just going to go through and cut all the clips up and automatically name it. So scripts are dead easy to use. And so all you got to do is install MPV, EL, and Hydra, and add the sort of bit of code. And again, I've improved it as best as I can, considering I don't know any Lisp, so that it all has custom namespaces and it all gets loaded after the MPV package. Again, with eval after load, and you can see these have all got like a namespace prefix for this, so it shouldn't interfere with anything else, because if I didn't do that, it broke the org timers. So if I just come back, should be able to insert an org timer, which was broken before. I think, how'd you do it? Yes, now it's got one org timers. To show you that the timing thing's working, clock in. But basically, it should sort of create stuff in a format like this. Something like this, and you can have some text, like start point. And there's a way you can actually get the time codes to come in here. So let me just quickly try and get the time code to come in the org format. For some reason it's a bit, you've got to have your cursor in a certain place or something, or yeah, I always had trouble getting it to work, but it's supposed to sort of insert the timestamp in an org timer sort of format, but I've found it a bit sort of flaky for some reason. But the org timers do work, and let me just switch back to the .el. So doing it like this with the eval after load and the custom namespaces shouldn't interfere with anything else. And this is all the sort of new code that I've added, and also the hydras and some other options. So we've basically seek backwards, forwards, backwards and forwards the frame, pause, quit, insert the playback position, insert a new line into the document, and also take a screenshot of the video at the current playhead position, which will get saved in the same place that you actually open the org file from, or you've got emacs open from. So that's the whole thing. And let me just switch back to the desktop and give you one last sort of look at the interface. So F2, and you've just got this nice interface showing you all the commands you can use, what they do, so that you can easily go through, insert the playback positions. You can jump to the playback positions easily, and it just makes it really easy to go through a video, mark out the bits you want, run a couple of scripts, and boom, it's going to chop everything up to the millisecond. So just like using a video editor, yeah, it's just like using Final Cut Pro. But the issue on Linux is all the open source video editors are awful, every single one of them. The only one that's any good is DaVinci Resolve. The problem with the free version of DaVinci Resolve on Linux is it doesn't support H.264 video. So you can't import H.264 video, import or export H.264 video with DaVinci Resolve on Linux. You've got to convert it to something like DNX, which increases the file size by 10 times. So if you've got a 1 gig H.264 clip, you've got to convert it to DNX. That's going to increase it to 10 gig. And then you can import it into DaVinci Resolve. Then when you export it, you've got to export it as DNX again. So that's going to be another 10 gig. And then you've got to convert that 10 gig file back into an H.264 file. So actually using FFmpeg on Linux to actually chop stuff up is useful, because all the video editors are awful, and the only one that's any good doesn't support H.264 in the free version. So that's using FFmpeg, MPV and Emacs to chop up a video into clips to the millisecond, and either doing it all within Emacs. You can do the whole thing within Emacs, or you can just take the timestamps in Emacs and switch to the command line and run a couple of scripts and chop the clips up to the millisecond. So that's all for now, and I'll put links to all this under the video.